In this video, we'll be looking at how to add a fit line to data in Fuse. We're going to be using the same data set we did for the error bars video, so if you've seen that, you already know what's going on. But essentially, we're scouring the stock market data for ways to beat the market. And the current theory we have is this. If I look at the years 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 throughout the decades that we have been following the S&P 500, the 1930s, 40s, 50s, and so on, the theory we have is that one of the years out of the decade, or maybe many of them, are going to have unusually high returns or unusually low returns that we'll wish to invest in or avoid. Or maybe there'll be a pattern that we can somehow exploit. And so what we've done is we've taken the data, divided up across these decades out to the 2000s, and then we have also taken the mean, where we have the mean is the average across these years. So the average of the year 0, the average of the year 1, the average of the year 2, and so on. We're going to go ahead and plot this data and then try to fit it. And also, from the video on errors, we have this plus minus column where we've included the standard deviation of the returns also across the year 0. And so we're going, when we plot this, to see data that has mean values with error bars symmetrically distributed about them, that is plus and minus the standard deviation. So let's go into Views and plot that. We're in Views with our data imported, ready to make a scatter plot. So along X, I'm going to plot the year. Along Y, I'm going to plot that mean value that already has error bars. Let's make this just a little bit easier to see. I'm going to widen out the year window to go to -1 so we can see quite a bit. And in order to make it symmetric, we'll make the other go to, so maybe this -2 and that to 11. Now we have our data centered. We're about to have a lot of lines. So we don't need to have the lines connecting the data points. That'll just make it harder to see. So making sure we're working on the scatter plot, I'll go to the line that's connecting the data and tell it to hide that. I'm also going to go back to the main and say that I would like my error bar style to be bar ends, and I'm going to make the error bar style a little bit thicker, just so it's easier for me to see those lines. Alright, the last thing I'll do is let's widen the Y window just slightly so that we can also have a nicer look at both the data points and their error bars. Looks like the max maybe should be at about 0.5, and then the min maybe at 0.3, -0.3. And now we have data that's centered in this window, and we're ready to try to fit. Alright, let's go ahead and do that. The way that we fit the data is to select the Fit button. So we'll go up to our button menu. You'll see that we have this button with a line in green across these magenta points, and when we click that, it will add a new element called Fit 1. This will allow us to fit data. What we need to do is go down to below this into the Properties pane directly below. Down in this Properties pane, we find a button that says Fit Function. That's how we're going to initiate the fit, but we're not quite ready yet. We need to define the function. Although I do want to point out that as soon as I added Fit 1, we already have a line. And the line that we're shown here is the line associated with this function, this linear function a plus b times x. And the parameters that that line is displaying is for a equals 0, so we're crossing the intercept at 0, the y-intercept at 0, with a slope of 1. That's the line we're being shown. We want the line that fits this data though. And so what we need to do is, let's say we want to explore the possibility that a line is the correct thing to use, then I need to change the data to reflect that of what's being plotted. So under this data tab here, let me actually take the Properties pane and make it bigger so that we can see everything. I'm going to take the X data as the year, the y data is the mean, and now when I press fit function, it's going to try to give me the best fit line to here. We can see immediately two things happened. One, the line changed, and this new console window popped up, and now it went away. We'll bring up the console window in just a moment permanently, but for now let's just look at this line. I have a nice thin blue line, and if I want to change how it appears, I could go to the editing pane, make sure I select the fit, and then over here we have all the standard features. We have a line, so we can control how many steps that line has. We can choose to hide it or not. We can also change the color, so let's make this a nice light blue, and then how about a much bolder line so it's easy for us to see. You can also tell maybe that the blue line is behind the red error bars. We can control that by taking this line and moving it up. Now it sits in front. It also changes the color of the data points because that's on auto. And I can move it back down. Maybe. All right, well, we'll just move this point up. All right. So we have this fit line. How do we interpret its properties? Back under the Properties tab, there's a few things that I can see when I have fit selected. And that is as follows. I have the function that I fit. I have the parameters. If I widen this window a little bit, it might show them all to me. It's telling me what I fit it against. It's showing me if I toggle fit range only, it's not going to do anything now. And we're probably not going to need this right now for this class. Here's the actual expression that it yields. We have the slope, b, times the year, and then the parameter a is the intercept. And so it's immediately giving us the equation that one might actually use if you wanted to calculate the values itself. It's giving us the chi value and the reduced chi-squared value. It's telling us that the function is fit as a variable x. I can give this a title if I want for a legend. It's telling me that the x data is plotted along the x-axis and the y-axis in case we had multiple axes. And then the last thing that's sort of interesting here is I can adjust the fit range. So let's say, for instance, that I was looking at this fit and I thought, oh, this is all nice, but there's some noise here. So maybe what I really want to do is just see what happens if I only fit the years 1, 2, and 3. That would mean my minimum fit range is 1, and my maximum fit range is 3. It looks like this is stopped short of 1 and 3, and that's because we have too few step sizes for our fit line. So we'll go to main and increase this to 500. And now you can see it stretches from 1 to 3. If I go back over to the fit and say fit function, then I'll get a line now. You can see it popped up the console window. We'll get there again still. I now have a line that's fit to just these 3 data points. And as long as I don't refit it, if I go back and say auto, it'll stretch out through everything. If I go back up and say fit this function, it'll go back to level. One thing that's interesting is this console that keeps popping up. So let's just look at that real quick. I'm going to go to View, and then, Tools. I would like to have the console show up, and I was right the first time. It's actually under View, Window, Console window. And what console does is it tells you what the program is doing. We made a fit, right? And so it's telling us the fit result A. This is nice. This wasn't present before, but the error in the fit, B, the slope, and the error in that fit parameter, as well as the chi and the chi-squared and the degrees of freedom that are associated with that fit. Okay, so there's 2 things I want to do now. We basically at this point know how to fit data to this line that was the default fitting. We know how to format the line that comes out. We know how to control the range. We know how to read out the results of this fit. as well as see the errors associated with those fit parameters. The two things that are left is how to fit a line without taking into account these error bars. Right now, we have Vue's defaults to making a fit line that is weighted by the error bars. And so these points that have the largest error bars contribute the least. If I would like them all to be fit equally, which is what happens in Excel, I need to get rid of the error bars. The way to do that is to go back to the data. In the data, we can remove the plus minus column. So let's just say clear content. So I can always say undo if I want it back. I will save this data, and then I'll go back to Views. When I'm in Views, I'll hit reload to get the data without error bars. And now if I hit fit function, which I'll do in a moment, you'll see that this line will change because it's no longer fitting weighted functions by the size of the error bars. Okay, so when this console window disappears in just a moment, you'll see that this line is much flatter. It's not capturing these data points correctly. And so this is sort of an issue actually with Views, is that when you have data without error bars, it does a poor job fitting it. So let's go put the error bars back so it knows how to do this weighted fit. We can do that in the data by just saying Control Z to undo, saving the data again, then going back to Views and refreshing to get the error bars to return. And then if I fit, then we have our line back that makes a little bit more sense. All right, now we know how to fit data without error bars, although it's not extremely useful in Views. You'd be better off giving data all equal error bars actually. And so let me add one more thing, which is how to do that. Let's go back to the data real quick. We're going to basically trick Views into fitting things correctly. And so I'm going to just make all these errors the same. Let's say 0.1. All right. And then 0.1 all the way down. Now we're going to have data that all have the same size error bars. And that means that they're all going to be weighted the same. Back in Views, we can refresh. Now we have error bars that are equally sized. I'm going to say fit function. Now I have a function that looks much more reasonable in terms of its fit, but it did in fact change from where it used to sit when it had error bars of unequal size. Okay, so we at least know how to force something to fit across data without error bars. We could always go in then, let's say we wanted to have data and make it look like it doesn't have error bars. I can always go to this formatting pane, to the error bar section, and then hide these error bars. And now it looks like we fit data without error bars. We have the same result that we normally would expect. Okay, last thing. What if we decide that a line is not the best fit for this data? It's the stock market. It's complex. A line's not going to cut it for us. So let's try a different fit. We're going to add in a new fit. We're going to go to Properties, and it's going to be this green line. So let's go ahead and just make that line thick so that we can see it and maybe give it a little contrast in terms of its texture. So we'll make it dotted. Now we can see this green line. Haven't fit it yet. I know back in this fit properties pane, I want to fit it to year and to mean, but a line's not going to cut it. So what if we had a polynomial? How about this? I say we'll fit it to a third order polynomial. So how about a times x cubed? One thing you can do in Views is this double asterisk for exponents. So you should read that as a times x cubed plus b times x squared plus c times x plus d. And now I have a third order polynomial. What you'll see is that I have a function that has parameters that are not yet defined. There's no initial guess. So as soon as I click off of this, Views is going to give me a warning that says cannot evaluate. It brings up the console to say that it's having problems. Basically, it's telling me that I have A and B defined as parameters, but not yet C and D. So I just need to give them guesses. So we'll say C, sure, C equals 1, who cares? D equals 1. And now everything's defined. And when I hit fit function, it'll try to find a minimum for us. And there we go. Now we have a new fit function that is this polynomial line shown here. Here are the parameters, the values that we have fit. I have something about the reduced chi-squared, the chi-squared, and if I wanted to, I could also again go to View, Window, Console, and then I can see not only the parameters, but the errors associated with these parameters. And with that, this is how you can fit data in views to complex functions. There's really not much of a limit. You can do nonlinear equations as well, and it does a fairly good job in views fitting those types of equations. So have fun looking at data and searching for patterns if you're into that sort of thing. I am.